Okay, you guys had asked that I did some more examples with your dividing complex numbers. So whenever you're dividing complex numbers, you're going to look at your denominator and you're going to multiply by the conjugate of that. So the conjugate just changes the sign. So instead of 6 minus 4i, it's 6 plus 4i. I'm going to do that for the top and bottom. And then I'm just going to FOIL there. So on top, 10 times 6 would be 60. 10 times 4i would be 40i. I times 6 is going to be 6i. And then I times 4i is going to be 4i squared. If you remember, I squared is the same as a negative 1, so that's really like a negative 4 right there instead of the 4i squared. My denominator, 6 times 6 is 36. 6 times 4i is going to be 24i. Negative 4i times 6 is going to be a negative 24i. And then negative 4i times 4i, is going to be a negative 16i squared. And again, the I squared is really like a negative 1. So negative 16 times a negative 1 would be a positive 16. On top, 60 minus 4 is 56. 40i plus 6i is 46i. My denominator, 36 plus 16 is going to be 52. 24i minus 24i just cancels. And every time your denominator should just be a real number. You should not have an imaginary number. That is why we multiply by the conjugate, so that we don't have any imaginary numbers in the denominator. That does reduce. 56 over 52 is going to be 14 over 13. And then 46 over 52 is going to be 23 over 26i. And that's going to be my final answer. Okay, so on this one, I'm going to multiply by my conjugate again. So 3 plus 10i and 3 plus 10i. On top, or for my numerator, negative 10 times 3 is negative 30. Then I get a negative 100i and a negative 3i, and then a negative 10i squared, which is really like a plus 10. In your denominator, 3 times 3 is 9. I'm going to end up with plus 30i and then minus 30i, and then I'm going to have minus 100i squared, which again would just be plus 100. Negative 30 plus 10 is negative 20. And I'm going to have minus 103i. My plus 30i and minus 30i cancel in my denominator. I'm just left with 109. This one, when you simplify that, because that doesn't simplify any, neither the real number or the imaginary number can be simplified, I would really take it either way. So you could leave this as one big fraction here. But if they simplify, you definitely have to separate them. This would also be acceptable. So either one would work, only because that doesn't simplify. Number 6, multiplying by the conjugate. Oops. So that's 10 plus 4i. 10 plus 4i. For my numerator, I'm going to end up with 20 plus 8i minus 10i minus 4i squared, which is really just plus 4. On the bottom, I'm going to end up with 100 minus 16i squared, which again would just be plus 16. Because I knew those two middle terms would cancel, the positive 40i and the negative 40i. I didn't even write it down. On top, that's 24 minus 2i over 116. 24 over 116 will simplify to 6 over 29. And then 2 over 116 is just going to simplify to 1 over 58i. So that's my final answer. When you're graphing complex numbers, you graph the real number on the real axis, the imaginary number on the imaginary axis. You have to have these labels when you do your graphs. My real number here is 5, so 1, 2, 3, 4. 1, 2, 3, 4. So I come over to 5. There is no imaginary number, so I'm just going to stay right there. On number 8, real number is 2. The imaginary number is -2, so I'll come down to my -2. Looking at those axes, I know they're kind of hard to see there, but that is 2, -2.